So now that we have multiplication of polynomials under our belt, we're going to go the other way and we're going to talk about factoring, which you could think about it as dividing. And what we're going to do is we're going to undo what we did before. And so let's start with things that look like the distributive law. And so let's consider factoring out our greatest common factor. And let's just jump into examples. I'm looking at something like 2x plus 6, and I'm told, examples, factor. If I'm looking at something like 2x plus 6, this is a binomial. And if I inspect it and I'm told a factor, I should be looking for greatest common factors. And 2x and 6 are both divisible by 2. So what I'm going to do is I'm going to divide both parts by 2 and bring it out front. And what's left over? 2x divided by 2 is x, and 6 divided by 2 is 3, so plus 3. And I just factored 2x plus 6. And this looks like the distributive law, but backwards. Not too much different. X squared minus 5x. Well, if I think about it, if I'm dividing x squared by x, I should get x. And if I divide negative 5x by x, I should get negative 5. So let's factor out an x, and I get an x minus 5. And in either case, I can double check my work. If I double check my work by distributing that monomial, whatever factored out by that binomial, I'm going to get what I started with. A little bit more complicated. Let's look at 2x squared y minus 7xy. And if I look at my coefficients, there's not much I can do with those, but I see x's in each one, so I know I can factor out at least an x. Turns out it's just x. And I see a y in each one, so I can factor out a y. And what's left over? Well, if I'm looking at 2x squared y, and I'm taking out an xy, I have a 2 left, and I have an x, but the y cancels out, and I am going to get minus 7 in the next part. And again, we can double check by distributing. And finally, there's a weird one. Let's look at 4 minus x. And you might say, well, it's a binomial and there's nothing I can do with that. But this is something that we're going to see pop up time and time again, where this is not in descending order, and things are separated by subtraction here. You really can't commute subtraction. And so one thing that folks like to do is they like to factor out a -1 or just negative. And if I factor out a -1, I'm going to get a negative there, and our -1 if you want to write, and it's going to be a -4 plus x. And we can rewrite that as negative x minus 4. And this gives us an idea of how we can switch the order of subtraction legally. And so in general, we say a minus b is negative b minus a. And this is something that's going to pop up time and time again. So if we think about it this way, we don't have to have that first step. And one last example with the factoring out a greatest common factor. If I'm looking at something like 2x cubed minus 5x squared, let's do minus 7x. And if I'm looking at this, I have a trinomial. And if I look at my coefficients, there's no common factor there. They're all prime numbers. So factoring out a negative is not going to do too much here because it's in descending order. But I do recognize there's an x in each part. And if I factor out an x from each term, I'm going to get a 2x squared minus 5x minus 7 with an x on the outside. And so what this says to me is that really it doesn't matter how many terms I have, the distributive law still works. And I can factor a common factor out of any number of terms. And that is annoying. So let's talk about factoring by grouping. And this is something that you're going to see from time to time. And the way it works is if you look at something like x squared plus 2x plus 4x plus 4, you might say, hey, I can combine my like terms, but we don't necessarily need do a 2x plus 4. I made a mistake there. You could say I can combine my like terms, but we don't want to do that just yet. When you were factoring by grouping, what you want to do is you want to pair off terms or make pairs of terms. And what I'm going to do is I'm going to look at the pairs. I have x times x plus 2, and then I have a plus 2 and an x plus 2. And we're going to use the distributive law where this is AB times AC. I'm sorry, BA, CA. So it's a little bit backwards. And what I'm going to do is I'm going to factor out that thing that I'm calling A. And what I'm going to get is B plus C and A, which is x plus 2. In this case, this is a perfect square trinomial. And so it works with anything. If I have it set up in a certain way where I can factor out a greatest common factor from a pair, then we can use factoring by grouping. So if I look at x squared plus 5x minus 10x minus 20, oops, that's 50. Something didn't look right there. What I'm going to do is I'm going to organize it, and I'm going to look at that pair. That doesn't, sometimes you have to move some things around, but in general, you can, you could, a lot of times they're cooked up to where you can just look at the pairs next to each other. And what's supposed to happen is we're supposed to get the same thing inside of our parentheses if we're factoring by grouping. And I'm going to get an x plus 5. And what's left over? There's an x minus 10. And that's kind of how you do factoring by grouping in a nutshell. Well, not kind of, it is. So now we need to move on to things more general. So we're going to factor trinomials that are in the form of x squared plus bx plus c. And when we're factoring x squared plus bx plus c, this is the easier case than the general case where we have something that's not one in front. And so with these, I like to build my answers. So I'm going to just teach by example. And we're going to undo multiplication of polynomials. So let's look at example 1 of x squared plus 5x plus 4. Okay. So if we're told a factor, what they want is they want this trinomial to be split up into a product of linear factors. And I know that x squared is x times x. So this is why this is the easier case, because I don't have to worry about making a coefficient out front. And in the next video, we're going to talk about the general case, which could make a lot more work. But I know x times x is x squared. And if you remember, I want binomials multiplied together. So I'm going to be multiplying x by x. I also know that I can make 4 as 1 times 4 or 2 times 2. Okay. And this is going to give me a clue at what I should put at the end of my linear factors. So I need to make 4 through multiplication. So one of these work. But then I need to add the two together, because when I multiply things out, that's going to give me my middle term. So 1 plus 4 is 5, and 2 plus 2 is 4. Take a guess which one we need. Okay, so I need the 4 and a 1. It doesn't matter where I put them right now, because I'm making a positive 4 through multiplication, and I'm making a positive 5 through addition. And if you remember, we need signs going here, and that's going to tell me that both these need to be positive. So if I have a positive constant, these signs have to match, because the constant terms multiply together to get that. And if I want it positive, it's either negative negative or positive positive, because either way the result's positive. But if they multiply together to get positive, and I add them to get positive, they both have to be positive. And in order to check, you can multiply it out, and really it's the middle terms that are usually going to trip people up, because x squared is x squared, 1 times 4 is 4. So folks will usually check those and be fine, but really it's the middle term that you really have to check. 4x plus x is a 5x, so that indeed works. And so our answer will be that part right there. If I'm looking at x squared minus 7x plus 10, I'm going to start building my answer, because I know I need a product of linear factors. And x times x is x squared. And I know I can make 10 with multiplication by 1 times 10 or 2 times 5. Okay, but I need a positive, so I know I'm going to have to have matching signs. I need a positive 10. But I want it to add up to negative 7. So basically, I want to have two negative numbers added together. It gives me negative 7. If negative 1 and negative 10 gives me a negative 11, negative 2, negative 5 gives me negative 7. Hey, guess what? Minus 2 minus 5. And again, you can check this out, and this one does check out. I'll let you pause it and multiply it out. Make sure that you get x squared minus 7x plus 10 when you do your work. And the last type is when I have that negative constant term, and these are the hardest cases. I know x by x is x squared, but I have to make a negative 18. So let's think. How do I make 18 with factors? 1 times 18, 2 times 9, 3 times 6, and I've exhausted all my possibilities. Okay, so I know that I'm going to have a combination of those, either 1 and 18, 2 and 9, or 3 and 6. I got to figure out which one works. And I know that my signs are going to be different because I need them to multiply together to get negative 18. And the only way that works is if I have a positive times a negative. Now we got to figure out which one's which. So the way I think about it is I'm going to look for the difference. I need a negative 3 here, so I need these values here to have a difference of 3. Well, that's a difference of 17. That's a difference of 7. There we go. 3 and 6 have a difference of 3 in one another, right? So, but I know that plus 3 minus 6 is going to be negative 3. So I know the bigger number has to be negative because this term right here is negative. If this is a positive 3x, I'd want minus 3 plus 6, but I don't have that. I have a negative 3x. And these you really do need to check because getting that middle term can be really tricky because subtraction is addition's tricky friend. So, and again, I'm going to have you pause it and check it. That one does work. So make sure when you're working through these, you check them before you put them in the homework software or on a test. These things do check themselves and it doesn't take very long. So in theory, you should be able to get things right every single time with a final answer because you have plenty of time to check things. All right, I will see you in the next video when we talk about more complicated, where that linear or that first term is not a 1x squared, it's going to be an ax squared.